Hello class, welcome to our first lesson dealing with section 7.5, which deals with scale drawings and scale models. One thing that I want to caveat kind of before we get started on this is that this section tends to be pretty difficult for students. So we're going to take the next couple class periods and discuss some of these pieces dealing with scale drawings. And if you're confused still after kind of the first go through in the first day, hopefully it'll get a little bit better with day 2 and day 3. As we move forward in this section. So let's go ahead and get started. Before we get into scale drawings, I just want to review some things about equations. So this says to write and solve an equation for the situation, which means you need to write an equation and solve it, kind of like the two-step equation ideas that we've done in the past. This says I went to the store to pick up some posters. I also bought a $5 DVD. I ended up getting 11 posters and 1 DVD, and the total was $23.92. Okay, the big assumption here is no tax right now. Okay, so it should be 11x because I bought 11 posters. What's missing is the cost of a poster. Notice here on the left side I defined my variable to be the cost of one poster, and then plus 5 equals 23.92, and then you do your two-step equation work by subtracting 5 on both sides, and then divide by 11. And remember, this is the cost, so it should be to the nearest cent because it's money, and that would be 1.72 or $1.72 for your final answer. But you want to make sure that you write an equation and set that up in kind of a two-step equation approach in order to get that solution for the question. Okay, when we look at scale drawings, here's the idea. Okay, this is like blueprints or a map. You're looking at something in a different scale. Okay, so like this blueprint is of the food court. So it's a small version of what the large actual food court is. Now it says the diagram shows that each centimeter is 40 meters in real life. So the scale then is 1 centimeter on the diagram is 40 meters in real life. Now you're going to need a ruler for some of the measurements from your book. If you're using the ebook, that might be a little bit more challenging, but you need to probably use 100% zoom, and that might get it what it needs to be the right size. If you don't have a ruler, I would suggest printing one off from one of the websites that has a PDF of a ruler you could have. Also in class, if you need one, then we can get one to you as well. But when you're looking at these questions, the distances aren't meant to be challenging distances. So they're probably things like a whole centimeter or half a centimeter. Right now, you're probably not going to get something that's 2.3 centimeters, for example. So that's something to keep in mind. What's nice about this one is it's on a grid, so it doesn't matter if you have the measurement tool or not. Each one of these grids is supposed to be 1 centimeter, each one of these distances. And so the length of this food court is 4 centimeters and the width is 2.5. Now, in order to figure out the actual length and width of the food court, all I have to do is set up a proportion. So here's the width. My ratio, or my scale, is 1 centimeter is 40 meters in real life. That equals 2.5 centimeters in my picture compared to x in real life. If I do cross multiplying, I'll get 100 equals 1 times x, so it's 100, but remember that's meters because it's the real life situation. For some of you, you're going to try to just do this times 40 divided by 40 because it's 1 to something. You shouldn't always assume that that's going to work because if we give you a different scale, the cross multiplying idea is going to help you out. So that's something to keep in mind as you're looking at these. To find the length, it'd be 1 centimeter to 40 meters equals 4 centimeters to x. Cross multiply and I get 160 meters. What you should notice here is if I take the drawing length, which is 4 centimeters, compared to 160 meters for the real length, or 2.5 centimeters versus 100 meters for the width, those always will simplify down to 1 centimeter to 40 meters, which is the scale of the object. So the reason this works is when you're looking at distances like length and width, and perimeter will be the same. If the scale is 1 centimeter to 40 meters, so is the scale of the lengths and widths and the perimeters because they're just distance. And I know that's a little confusing, and hopefully that'll keep getting a little bit better. You're going to be going over a lot of these topics again in 8th grade, so if it doesn't quite make perfect sense, that's okay. I would focus in on kind of more of letter B, which is using cross multiplication in order to find your answer. The next question says, take the same information we just looked at, but now 1 centimeter in the picture is 20 meters in real life. So now my scale is different. And their goal is to figure out what happens here. Now the common mistake is, the last one was 1 to 40, so this one's 1 to 20, so I just cut everything in half and divide by 2 and shrink it down. That's not exactly what's happening here, and I can show you very easily why just based on cross multiplication. The scale now is 1 centimeter in the picture is 20 meters in real life, equals X. I don't know the length of the scale, but in real life, it's 160. That's where this 160 meters came from the last slide. When I cross multiply that, I get 160 equals 20x, and then I divide by 20, and I should get 8 centimeters. This is a simple cross multiplication of that situation in order to find that. So what happens here is instead of 4 centimeters, it's twice as large. This idea seems backwards because really what's happened here, and you could do the same thing for the width, is instead of being a 1 to 40, you're 1 to 20 and you've zoomed in. Okay, and because you've zoomed in, think about it like on a tablet or something when you zoom out and zoom in. Okay, zooming in actually makes the object larger, okay, in your picture. And so because of that, you've zoomed in, and so you've doubled all the lengths and widths because the scale has been cut by a factor of 2. Okay, this next one, I like the wording of this question because it doesn't require a ruler at all. It just says each unit represents 8 inches. So the scale is 1 unit for every 8 inches. And so this would be a 6 by 6 if you just look at the square, the big square. So this is 6 units by 6 units. If you set that up, it'd be 1 unit for every 8 inches. So 6 units would have to be 48 because it's just a times 8 situation. Or you can cross multiply to find the answer. The sketch length and actual length would be the model to real life or the sketch to real life will also be 1 to 8. If you just look at this, 6 units is 48 inches and divide both of those by 6, that would be the same as 1 unit is 8 inches. And so that's where that idea is coming from for those types of situations for this question. The next one says take that same information, but now each unit represents 2 feet. Now here's the key. If the last one was 1 unit is 8 inches, if you want to compare to what's happening here, you're going to have to make sure it's inches. So don't assume like, oh, it went from 8 to 2, so that's zoomed in just like the last one because the units don't match. So my suggestion is you make it 24 inches. Okay, you got to make sure the units match up when you're cross multiplying these. So 1 unit now is 24 inches because that's 2 feet equals x over 48. When I cross multiply this, I get 48 equals 24x and divide by 24, and I get 2. So instead of 6 units on each side, it's divided by 3, and now it's 2 units on each side. Because the old scale was every 8 inches, and I multiply that by 3 to every 24 inches, which means I've zoomed the picture out so that I can see it from a kind of a different perspective. So, still making sure of cross multiplication, but the units of the numerators have to match, and the units of the denominators will have to match up in order to make sure that you can cross multiply. When it comes to reducing or enlarging the drawing, all we have to do is change the scale in order to figure that out. So if we want to make it smaller, we can zoom in. Zoom out, excuse me. If we want to make the picture larger, we can kind of zoom in to make that picture larger. It's still a kind of a difficult idea, but we'll keep working on it as we move through the next couple class periods. In terms of this table, what I've done is found the perimeter and area of the actual food court and all the different drawings that we did. So if we go back to the food court questions, so here's the original food court. So to find the perimeter, I added pieces together in order to find that. And then same thing with the area. So I just added up length plus width, okay, 2 of each of them to find the perimeter, and did length times width to find the area. And I just did that for my original picture, the actual one, and then my new picture right here. So I just did that for all 3 of them in order to figure out what these numbers are. Here's what's important. Let's look at perimeter first. So perimeter's right here. So if I take my original drawing divided by the actual object, 13 centimeters divided by 520 meters, and I divide both those by 13, I get back to the original scale of 1 centimeter to 40 meters because perimeter is just a distance. So it should be the same exact scale. Similar for my other drawing, the 26 and the original of 520, divide both those by 26, I get 1 centimeter to 20 meters, which was the scale of that picture. Area, however, is not as simple. So for area, if I take the original drawing divided by the actual object, you'll notice it's 10 and 16,000, which is 1 over 1,600. And if I do the same for the other picture, it's 1 over 400. What you'll notice here is what you want to start to realize, and again, this will take time, okay, to start to figure it out. So don't focus as much on this aspect as just finding the numbers with cross multiplication. But if the scale is 1 to 40, what you'll notice here is if I square both of these numbers, because its area is something squared because you're doubling or you're multiplying something length and width, okay, if I square this, 1 times 1 is 1, and 40 times 40 is 1600. So if the scale is like a 1 to 40, the area scale is 1 to 1600 because it's those numbers squared. Similar for the other one. It's 1 to 20, and then I square them, and for area, that'd be 1 to 400. Okay, if it's area, whatever the scale is, it's going to be kind of squaring that scale number to figure out the difference or the multiplication between those two things. And as I just mentioned, focus in on just finding the answers for these numbers. Okay, we can always divide out ourselves, and it doesn't require like any extra knowledge to find that. All I would have to say is find the perimeter of the actual object, find the perimeter of the scale, and divide them out, and then you can see what the relationship is. So you don't have to have any of the shortcuts right now. I'm just trying to give you some of that info because you're going to be looking at that later on in your different classes. Okay, your homework today is fairly short, but it requires some measurement on questions 4 through 7. Okay, some of the questions say, what are the dimensions? Dimensions are the length and width of the object, so there's a lot of rectangles there. You're going to need to measure some things. Remember, if you're using the digital book, probably use 100% scale so you can see it. That's really the least of the issues. But if you get something that's like 3.9 centimeters, it's probably 4 centimeters right now. On the last group of questions, please make sure, if you're not sure how to find some of those things with graphing and things of that nature, make sure you look up some of those pieces. You could use one graph if you're trying to graph multiple things. So you could use one coordinate plane in order to do some of those pieces. Have a good day, everyone.